So, we found the owner of the notebook. That's good to know. So he has all of his notes from day one. In case you are missing a cover of your cell phone, because we found a really nice looking cover, then it's going to be picked up at the wardrobe that was found. And in case you lost anything else, just let us know. Typically, we have the little lost and found, as I said, up where the wardrobe is. Now, the next talk is Carlos from de Colombia. Sí, mucho gusto. Bienvenidos in Austria.
Thank you.
I try to practice my Spanish because my wife is Colombian, as I told you, but at home I don't get to practice my Spanish because we have to speak German so that she learns it. So I only use Duolingo to learn it, and then I take every chance to practice. Carlos, a couple of things from you. You are obviously from Colombia, from Cali, and what this reminds me of, because I always assume, or people that come to Austria, a lot of them assume everybody knows how to dance waltz, right? All the Austrians in the audience, you all know how to waltz properly? Yeah, not all of you, right? So it's a stereotype. I always assume that everybody in Colombia is dancing salsa, but you don't, right? No. But it's a really fun dance. That's actually how I met my wife, salsa dancing. So you should try it out, even though you're a self-proclaimed nerd. I know you said this earlier, but nerdy people can also dance. Now, another thing, you moved to Munich and you just experienced Oktoberfest for the first time? All the drunk people in the U-Bahn?
Yeah, it's amazing to see the dark side of beer.
Well, the thing is, the others see the dark side of beer. The people that actually suffer from the dark side of beer, fortunately, hopefully, well, they see the pictures on social media about them not feeling well. All right, without further ado, what I want to say is that you're working currently for NVIDIA. Before that, you did Red Hat in the United States. And the project that you're going to talk about today is about how to detect node features. So if you're running Kubernetes on multiple nodes, then different nodes have different capabilities from a hardware perspective. So you show us how you automatically detect all these features, how you then tag it, and then also how you can enforce policies based on what the capabilities of a node are.
Yes.
Yeah. All right, with this, big round of applause for Carlos, and you take it away.
Thank you. So, hi. Actually, that's the QR code for the GitHub project. It's a Kubernetes 6 project, so it's an open source project. It's by no means from NVIDIA. Actually, it gets a lot of contributions from Intel and many other hardware vendors. And I'm actually here to talk about how can we automate this new word that is coming to Kubernetes, that is heterogeneous clusters, right? Like, we used to have Kubernetes as a single monoblock of like one node type or one cluster type, but now we are getting even into having multiple kernels, like each node has a different kernel, each node has a different OS. So we need a way to really find out where is my pod running, or to leverage the node selectors to tell my node, my pods or my deployments where to run. And I want to start with this really nice phrase that is, we advance as a civilization every time we automate something, right? So today, I'm going to teach you how can we automate a little bit, that is where to deploy your applications in Kubernetes. And like, what a better way to do this than using Bill Bobolson, right? Like, he was given a contract to do something very simple, but he didn't know when he was going to return or where he had to run it, right? Like, it's kind of when you deploy a pod and the pod doesn't know where it's going to run, it just knows what the code inside the pod is, but it doesn't know where the cluster is. And this was the promise of Kubernetes years ago, right? Like, Kubernetes was the dream of Kubernetes is to have a way where I can just deploy my application, and Kubernetes is going to handle the entire hardware, and all that is going to be abstracted from my deployment. But still, to these days, you get to see those big YAML files because I have to tell my pod to go and look for a specific node, and I have to do a lot of manual things to really target my pod where I need my pod to be running. And this becomes very important for me as NVIDIA because we need to deploy GPU CUDA-based containers in only nodes that have GPUs, right? So we really need to know where is my pod going to run. Who am I? As I was just presented, my name is Eduardo Arango for short. I started in the days of trying to get containers into science, so I still do a lot of containers for science, mainly. So I contribute from the ground up, so I contribute from container runtimes all the way up to Kubernetes. I did some years had also doing that for OpenShift, and now I'm doing that for NVIDIA, basically working to get containers to work for high-performance computing environments. So I'm going to talk about node feature discovery and all the automation features that it provides to us. So what is node feature discovery? So this is my favorite conversation of all times. It was actually the first time I laughed by reading a book. And it's when Bilbo and Smog start adding labels to each other, right? Like, I am the clue finder, I am the web cutter. And this is something we find, like, we do manually a lot in a Kubernetes cluster, and it's labeling nodes depending on the things that we want to know from that node. And still to these days, we do that very manually. So that's why NFD, the Kubernetes 6 project, was created, is we need a way when we have thousands of nodes to automate those nodes and to label them, and also not just label, but do many things. So NFD, the Node Feature Discovery project, is a project for that, for allowing the nodes to add labels to themselves. NFD is composed by mostly 3 components. It has an external 4 component that was added in the last release that is called the garbage collector. Not going to talk about that because it's new, so we're just testing it, and it just has been like 1 month release. But the main 3 components is the NFD master, the NFD worker, and the NFD topology updater. Today, I'm not going to be talking about topology updater. It will require an entire 30-minute talk. But for those, there is also this big push in the SIG scheduling for being able to do NUMA-aware scheduling in Kubernetes, right? Like, this is a big portion of doing big runs in Kubernetes for things like training AI ML, right? So the NFD topology updater is basically the sidecar for that big push in SIG scheduling to be able to run NUMA-aware scheduling in Kubernetes. Today, I'm going to be mostly demoing NFD master and NFD worker. NFD, why the separation? The first release of NFD was actually 1 component, NFD, but users kind of let us know that using the automation of NFD could auto-label the node to become a master node, and then that would become very insecure. So that's why the separation became master and worker. Master node, the master pod, has more security restrictions and RBAC policies, and it actually tries to run on master nodes or control plane nodes. And the worker is basically a daemon set that runs on every available node, so nodes that are not control plane or master nodes that usually are tainted not to allow regular runners. So the NFD worker goes to each node in your cluster and runs a full search of hardware and also software now. So we are running from which type of CPU do you have, memory, storage. Does this node has USB plugs? Like, we have actually had that feature because someone needed to know which nodes have USBs so they can walk into the data center and manually plug some USBs. So we have labels for that. And also it has runs for OS features, like which operating system this is, and features like that. Until like the last 3 releases, we started using Kubernetes CRDs, so the API. And this is how the API looks like. It's called the node feature. So every worker node, every worker pod that is running on a node is going to advertise 1 CRD like this. So it's going to be the node feature, and as the label says there, node name, node 1, right? So this way, we can have the labels created as part of the metadata of the node, but also if my process requires to, we can go and read or query by CRDs. And also, this allows us to read CRDs. So not just CRDs becomes a way for NFD to tell the admins what is happening on the node, but the other processes and the admin itself can create extra node feature CRDs to create extra labels on the node, which I'm going to be demoing later. As part of what is NFD, once you deploy NFD by default, like if you go to the GitHub repo and just do like a Helm install, this is how it will look like if you do a kubectl describe node on any node. It would advertise many things from OS release, kernel version, CPU model, if your CPU can do virtualization or not, if your CPU can, it's a lot. So it was getting out of hand, so that's why we started to introduce the concept of feature filtering. So you are not going to get all of this, but you can just tell NFD, like, I just need this, and this label. So automated node labels. So again, smoke. The automated node labels was created because it was getting out of hand, and also we found that for ITSI, the metadata of a node cannot exceed a certain amount. I think it's like 1.5 megabytes. So we developed a specific CRD that is called a node feature rule. And this is how it looks like. The node feature rule is a way for us to filter and create labels based on something that I'm looking on the node, right? So we develop a max expression for NFD. So we can go to the node and say, like, if this node has, like in this example, kernel module something, please create the label my sample feature is in this node, right? So this will run on every node of my cluster, and we'll label the nodes that actually have a specific loaded module. I can do this by node name. I can do this by kernel version. I can do this by OS version. I can do this by hardware, by memory. And this way, I will automate how can I create labels depending on features that I'm specifically looking for. Example, at NVIDIA, we use this to find out which nodes have a GPU. And if the node has a GPU, we create a set of labels that then we utilize with the GPU operator. So your CUDA-ready pods can go and run there. So it's a very good way to automate and then target your deployments. I will be demonstrating this. Automated taints. I really like this part. Is like we want to control who enters and who doesn't enter a node by the features on the node. And this also comes to specialized hardware like GPUs, but not just GPUs, but let's say we have a cluster that is half the cluster is just like 8 CPUs per node, and the other half of the cluster is like big chunky nodes with like 64 CPUs per node. And we want to keep the big ones for a specific team or namespace in my organization, and the smaller ones for another use case, right? So we enable that by also in the node feature rule, if the node serves a specific type of node, right? Like if the node has a GPU, if the node has a AMD versus Intel CPU, right? Like I want to differentiate that for my deployments, I can then go and create taints. So I can automate how taints are created in my cluster and then reject specific deployments depending on the node type. That way I can automate who uses which type of infrastructure in my cluster. And one of the last features that was added in the past release was extended resources. And this is a good example. And we want to control which resources are being consumed, and not just by deploying applications and having them to have a resource allocation and leave Kubernetes to do that. I want to control what do I have in my inventory, right? And I want to, every time I do a kubectl describe node, I want to have an extended resource in the, when you do kubectl describe now, you get a capability in the entire YAML. So we can do that. And the extended resource also works through the node feature rule CRD. And basically, by adding the extended resource on the rules, we can create a specific resource discovery that we can then utilize from the node, pod deployment, and we can check by when checking the node. Here, I'm doing a very, very easy example that is the kernel version. But right now, we are using that at NVIDIA, and also I think Intel is using that for knowing the available virtualization slots that are in a node, and also for the confidential computing operator, the COP operator for short, is being used to advertise the available number of, how's it called? The security slot that you can have for a confidential container, and it will change depending on the number that is actually available on the node, and this is being refreshed every like 5 to 10 seconds. So now I'm going to be running a couple of demos of this. So here I have a Minikube cluster. So this is one where I'm not testing topology of data. It doesn't work for ARM, Apple, but yeah, that's one of the reasons. So I have a one node here, and I have an NFD running already in this node. So as we can see, it is running one worker pod, sorry, and so this is how it looks like when you deploy it by default, and it's basically advertising all the CPU capabilities of this laptop because it's running on Minikube. But then I want to show the Taints feature, right? So in the default namespace, I'm running a KCD orgs, following the Lord of the Rings kind of topic. And this is basically a daemon set that is going to run on any created node, right? So if I scale up my cluster, so I'm going to scale up my cluster, meaning I'm going to scale up also the daemon set. I'm going to scale up to 3 nodes just to So now the regular daemon set, the orgs, are trying to populate the entire cluster because I just scale it up. But now I'm going to create this, right? So let me highlight it so it looks better. So I'm going to create this automated taints that basically says on this last line, for all the worker nodes that are created, because I can do it by a regex expression, so I'm using this regex, that is not on the initial Minikube node that it only is called Minikube, but every added Minikube node is going to create a taint to reject running pods. Now it has created the taints and is removing the pods from the added nodes. It is not removing the initial one because it was the one running in the control plane, and these taints were designed by a regex expression that I specifically added in this line to create a taint on the nodes that are added, right? So this is a way that I can create taints for new added nodes. And why we did this feature, it mainly came from a comment in Slack from a user that he had a testing environment that can grow over the day and they scale down overnight. And he wanted to reject regular company deployments from eating the infrastructure that was being created for testing. So this Slack comment, like a year ago, created that need for us to, what if I'm starting to add more nodes in my AWS Google cluster, but I want to reserve those nodes because I know I'm creating them for a specific event that is happening today afternoon or something like that. So we can create a specific taints for that. Now, the second thing that I'm going to be showing as example is a regular node feature. So I'm going to be creating a node feature to add custom labels to a specific node, right? So I'm telling NFD for the node Minikube, that is the default for Minikube, add these labels, right? It's a very simple operation. Here they are. So I created extra labels in my node, not by running manually like kubectl, label node, label name, and maybe having like a bash script to do this automated for me, but I can actually have CRDs living in the cluster for when a node with a specific name gets created, it will get a specific labels that I have designed to, right? So this goes in lines also with like Argo CD and GitOps deployments, where you want to have nodes label as soon as they get created for a specific use reason, right? Like again, in my use case is when a new node with a specific type of GPU gets added, we want to label that and maybe reserve that if that GPU is virtualizable or not. It really goes to the use case. Another example that I'm going to be adding here is how to use the no feature rule and using regex to add specific labels for a node, right? So here I will be creating the added node label for all the nodes that have been added, right? Like minikube-m. So if we check the main node, it's not going to have the label, but if I check one of the added nodes, it has the label, right? So it added to each, yeah, I'm looping here through 02 and 03. So I can add specific labels depending on, here I'm using a very easy example that is the node name, but I can add labels depending on infrastructure, depending on operating system, depending on load, because we can also check for the usage of CPU, the usage of things like the extended resources that we use for virtualization and for confidential containers. And with that, yeah, I think I'm 5 minutes short. I try to keep my talks short. Thank you. Again, just going to leave the QR code here. It's a Kubernetes 6 repo. We are always looking for new contributors. We just released version 0.15, and we are aiming to have 1.0 by next year, hopefully, once the API stabilizes.
Cool. Thank you so much. And 5 minutes short means 5 minutes more for questions. See? Or 5 minutes early to lunch. But I hope there are some questions.
Between me and lunch. So
but there are people asking. And as Andreas is running over, in your demo, when you were adding the labels for Vienna, you had a little typo that I'm sure all the Austrians cut, because you tried to use the German name of Vienna, which is Wien, W-I-E-N, but you use W-E-I-N. It's wine. Yeah, but we like wine here too.
Yeah. And also, Vienna in Espanol is with one N, and English is with double N. So yeah, my head is messed right now.
Yeah, it's okay. So first question.
Thank you very much for the presentation. I'm not sure how to phrase the question, but if I want to add labels dynamically through some custom logic, is there a way to extend this tool to do that as a user? Or would I just need to add my own logic somewhere else? Is there, because now I see you can add, let's say, static labels based on some rules that you define in these custom resources. Is there a way to have some webhook or some custom logic that can extend this tool?
Yeah, that extended resources, where are extended resources? Here. So this that you see here is what we call a dynamic label, right? So you can have a label that actually changes over time, depending, like a simple example, like CPU usage, right? So you can define, like our regex and feature machine set is very rich, so you can do a lot of customization just by using the mash features, the mash expression, and also using the regex that we allow for creating labels.
How often is the evaluation happening then?
You can also set that. So if I have here is the project. I can maybe show that easier here. So on the worker node, that is the one that is doing the work, we have a flag where you can set the sleep time, right? So here, sleep interval. So you can set, like, by default is 1 minute, but you can set the sleep interval to be 1 second, less than a second. If your CPU can handle doing it many times a second, go do it. But by default, we think your infrastructure is not going to change every minute. So that's why it's a minute, the default. But we have a flag for allowing you to do that as you want it.
Other questions? Raise your hand. Yeah, over here on the other side, Andreas. That's okay. He's, you know, why do you think he's so fit? Because he's running around all the time.
Great job, thank you. Thank you for the presentation. One question, is there any way that I can be informed if my node feature rules override attributes? So if I use labels, the same labels into rules and they would override each other, is there something that informs me about that? Like, hey, you made a mistake there?
Oh, no. Just that the label won't appear in the metadata of the node. But
Okay, but you don't evaluate it when they get presented by the rules and merge them together then?
yeah, we do it internally, but since everything is happening through kubectl create, we cannot, like...
It's sequential and you don't get it all the time, okay.
Yeah, we don't have a bet rule for NFD, yeah. You will have to go to the NFD pod and check the logs. The logs will be splitting a lot of, like, reading CRD is not readable. But you will have, like, to go into the logs to see that your rule is not working.
Okay, thank you.
Yeah, learning to use regex and the feature matching expression can take some time, but once you start using it, yeah, it can become very rich. So yeah, even for me, creating the demo, I made a lot of mistakes with the regex.
All right, anything else? Go once. Over there. Yeah. Good.
Up.
How resource intensive is this? Like, since it's daemons.
Yeah, we, since this is a high performance computing environment project, we try to keep NFD as low footprint as possible, and on every feature we are, like, removing things. The entire feature discovery takes less than the last time we tested. It was like 30 milliseconds or something like that, and that's why we have a refresh of 1 minute. So every minute for 30 milliseconds, that's it, right? Like the CPU utilization of this is minimum. And now is better because before 0.14, we were using gRPC for the communication between the worker pods and the master pods. And so workers will tell masters everything that they discovered, and then master will communicate with Kubernetes to create the labels. Now we're doing everything through CRDs, so it's actually just the controller runtime that is working, so the CPU utilization has lower. So yeah, we try to keep NFD as low footprint as possible.
Yeah, really, really cool talk. Since you work for the HPC space, is this also supposed to, or maybe be used for scheduling as a whole, or is this completely different? Like, you know, are you also using this for job scheduling, or want to use it when you spin up new virtual nodes? I mean, theoretically, you could say somebody submits a job, and then you just tag it by the job name, and then those nodes get allocated or used for the submitted batch job. Is that at all what you're doing with this?
Yeah, so NFD, it's a side tool for schedulers, right? Like, this is not a scheduling project itself, but the main goal of NFD is to create labels, annotations even, because if I can show here, describe node, minikube. We create even annotations. So here, we create annotations and labels, and also I didn't demo the extended resources. We created resources.
Yeah, exactly. And I thought this is so powerful that you could also maybe use it directly for scheduling.
Yeah, no. So again, from NVIDIA and in other corporations, they use NFD to create labels, extended resources, to then use that for the node selector or to use that in their scheduling. And that's why one of the components of NFD is the topology updater. That is the one that is being used for topology-aware scheduling. So I work in a project with some USA universities where they are using the topology updater to schedule specific scientific workloads in Kubernetes that are NUMA aware, right? Like they need to be in a NUMA node with all the scientific components that get into doing that. So NFD is kind of like the perfect sidecar for all the schedulers that are coming into Kubernetes.
Awesome, awesome, thanks.
This Constanze, right? Yeah, because that's she gave the keynote yesterday. She also works at Technical University here, and I think you need to connect on this topic. Cool. You want to show another demo?
No. I was deploying the extended resources, but yeah, they appear up as labels as well.
Perfect. So with this, we are at the end. There's one more. Okay, that's the last one, and then we go.
Thanks. Thanks for the presentation. One question regarding the feature discovery. Is it actually checking this via the operating system, or does it also take into account, for example, device plugins installed and does some kind of sanity check whether this is even working before applying the labels to the nodes?
Yeah, as I did an example, we even go to check if the node has USB plugs and if the USBs are being used or not. Right, like we check hardware and software.
Okay, thanks.
How can I extend that? Is there a plugin system, or do I need to do a pull request?
Yeah, so for extension is the, here. For extensions is the node feature, where is it? The node feature API. So what, like as example in NVIDIA, what we are doing is the things that NFD is not discovering because are very like NVIDIA specific, so we cannot contribute them because CNCF policies. What we have is we have a sidecar container that runs, discovers all the GPU NVIDIA specific, and goes and create one of these CRDs that will create labels that are NVIDIA.io / and the specific feature of that GPU. So this CRD was actually designed for creating sidecar containers to advertise specific labels depending on the specific hardware manufacturer, right? Because as I said, like NVIDIA and Intel are like the main contributors to NFD, but also like network providers and like Dell, HP, and all of them contribute to NFD. So if they want to advertise some specific hardware feature that only exists for Hewlett-Packard or Dell, they do it via CR. Right? So you can just create a CR node feature to create labels for your specific hardware use case. So we do it via sidecars.
Awesome. Final round of applause for Carlos. Now it's lunch break. We are coming back here in an hour and 15. We got 3 more talks in the afternoon and then a surprise closing. And thank you so much. And Carlos, I think you will be around for a little bit longer in case there's more questions. Thank you.
It's the first time I talk about NFD.